Hello everyone, welcome to the channel HMPNs. I am Abhishek sir, and today in this video we will study about another very important topic of 10th science light chapter, that is refraction. Note that this is part 2 of the previous video. Let us quickly move on to the topic checklist. These topics will be studied in this chapter and in this video. So topics are refraction with examples, glass slab, laws of refraction, refractive index, lens and types, important definitions, rules and ray diagrams, uses of lenses, sign convention, lens formula and magnification, and the last topic will be power of lens. Now friends, in reflection we have seen that light ray was bouncing back in the same medium. It travels and bounce back after striking and it travels in the same medium. But have you ever imagined what happened when light enters from one transparent medium to another? Does it still move along a straight line path or change its direction? Now let us consider the case of the pencil or any spoon which is partly immersed in water. The light reaching you from the portion of the pencil inside the water seems to come from a different direction compared to the part which is above water. So that is the reason why the pencil appears to be displaced at the interface. You see, there is a slight displacement of pencil. It appears little bit bent. Even if it is pencil or if it is spoon, in both the cases we are seeing that there is a bending. So what exactly is refraction? Refraction is the phenomena of bending of light when it travels from one medium to another. So change in direction or bending of light is nothing but refraction. Now quickly going to the next topic, that is refraction by glass slab. Over here in this figure we can see a glass slab ABCD, the rectangular glass slab. You see PQ is the incident ray, then it goes inside the glass slab, so it becomes QR, and then it comes out of the glass slab, it becomes RS. So PQ is incident ray, QR is refracted ray, and RS is emergent ray. Now you see dotted lines. N1, N2 is the first normal, N3, N4 is the second normal, and from Q to C towards C, there is another dotted line that shows that if there wasn't any refraction, light would have traveled in that path. So you see there is a slight displacement from the original to the actual path. That displacement is called lateral displacement. Now see, when the medium changes, there is a slight bending. So both these arrows are showing where the bending actually happened. Now important thing to know that if we replace the glass slab with a triangular glass prism, the result would be the same. The light ray will bend. And a common pattern that is observed, that if the light rays are moving from rarer to denser medium, it bends towards normal, and if it moves from denser to rarer, it moves away from the. Now, as you are familiar with the phenomena of refraction of light, now let us know what is the cause of this refraction. Refraction is due to the change in the speed of light as the light ray enters from one transparent medium to another. What is the keyword? Speed changes when the light ray moves from one medium to another. Now, experiments show that the refraction of light occurs according to certain laws. So, these laws are called laws of refraction. The first law is the incident ray, normal, and the refracted ray all lie in the same plane. Second law is a very important statement, also known as Snell's law. It says the ratio of sine of angle of incidence to the sine of angle of refraction is constant, and this constant is called refractive index. Now let us study refractive index in another way. Now, we all know that the value of refractive index of a given pair of medium depend on speed of light in them. So, if we want to represent refractive index, if we want to find out the refractive index of medium, of any medium with respect to any other medium, we will have to take care of the speed or velocity of light in those medium. So what we have to do? We have to do the ratio. Suppose here v1 is velocity of light in medium 1 and v2 is velocity of light in medium 2. So what is refractive index of medium 2 with respect to medium 1? It is eta 21 equals to v1 upon v2. What is that small n? It is not actually an English alphabet. It is a symbol which is called eta. Now if we replace any one medium with vacuum, so that becomes absolute refractive index. So the refractive index of any transparent medium with respect to vacuum or even air, that is called absolute refractive index. So for example, you can see in the figure eta of glass. So how to find out absolute refractive index of glass? So you just have to divide the speed of light in vacuum upon speed of light in glass. So that is how you find absolute refractive index. Now moving on to the next topic, that is image formation by lens. But before that, let us study what is a lens and what are the various types of lens. So what is lens? A transparent medium bounded by two surfaces of which one or both the surface are spherical. So based on that, we divide lenses into two types, that is concave lens and convex lens. Now see from the figure, if it is thin at the center, if there is a cave in the middle, if it is thin at the center, it is called concave lens. If it is thick at the center, it is called convex lens. Now in the bracket I have written few words, converging and diverging. So that we can understand by these two figures why it is called converging and diverging. So in convex lens, when light rays are coming from one side, they converge to a single point, and that is why it is also called converging lens. But in concave lens, the light rays from one side, they will tend to move away, they will tend to diverge away. So that is why we have to bring them back to a point, and that is why this lens is called diverging lens. So convex lens, converging lens, concave lens, diverging lens. Now these lenses have two surfaces which are curved. So we have to imagine that both the curved surface forms a part of some imaginary sphere, right? See in the figure, for both the surface in both the lenses, we have an imaginary sphere. So we have defined two definitions, radius of curvature and center of curvature, based on this figure. Now what is radius of curvature of these lenses? It is the radius of spheres from which the curved surfaces of the lenses are formed. What is center of curvature? It is the center of the sphere of which the surface of lens forms a part. So based on these imaginary spheres, we are defining radius of curvature and center of curvature of lens. Moving on to the next set of definitions, we have principal axis, that will be almost similar to that of what we have seen in mirror. A principal axis is an imaginary straight line passing through the centers of curvature of the lens. So it is an imaginary line passing from the center. What is optical center? Optical center is the central point of a lens on the principal axis. Remember, we have a similar concept of pole in the mirror. So if it is lens, then it is not pole, it will be optical center. Next is the effective diameter of the circular outline of the lens, which is called aperture. So it is nothing but the diameter of the lens. Now the last definition is principal focus. We have defined principal focus based on the nature of light rays into two, one for convex lens and one for concave lens. When rays parallel to principal axis are converging at a point after refraction, so that point is called principal focus of convex lens. So they are actually converging to the point, so that point is called principal focus. Rays parallel to principal axis of concave lens are refracted such that they appear to be diverging from a point on principal axis. That point is called principal focus of concave lens. Remember, diverging lens, concave lens is diverging lens, so rays will not actually meet, they appear to meet to a point, and that point is called principal focus of concave. Now next topic is ray diagrams. We can represent image formation by lenses using ray diagrams. For drawing ray diagrams in lenses, just like spherical mirrors, we consider any two of the light rays and then we see the manner in which they are refracted. So we have to follow certain rules before we go to actual image formation and ray diagrams. The first rule is rays parallel to principal axis will pass through principal focus in case of convex lens, and obviously it will appear to be coming from principal focus in case of concave lens. The next rule says that rays passing through optical center, it will emerge without deviation. So without deviation it will pass through the optical center in a straight manner. And the third rule is that rays passing through or directed to focus will emerge parallel to the principal axis. So by these three rules we will be seeing the next topic, that is ray diagrams. In also this topic we will discuss how the image formation is there by convex lens, and then two of the examples of concave lens image formation also we will be seeing. Note that in ray diagrams focus on the figure and four things you have to take care: position of object, position of image, nature of image, and size. So it's quickly starting with the first one. If the object is at infinity, the image will be formed at f2, nature real and inverted, and as image is very small, very small, it is not seen, so it is highly diminished. Moving on to the next set of figure, that is if the object is beyond 2f1, the image will be formed on the other side between f2 and 2f2. Nature, again the rays are actually meeting, so it is real and inverted, and as compared to the object the image is slightly smaller, so it is diminished. Now the third figure, if the object is at 2f1, what will happen? The light rays will refract and converge and meet to the other side exactly at 2f2. You can see from the figure nature is real and inverted, and again comparing the sizes, the size of image and object both are same. Now moving on to the next figure, if the object is placed between 2f1 and f1, the position of image will be beyond 2f2 on the other side, nature real and inverted, and size is magnified, that is larger than the object. Moving on to the next figure, if the object is at f, what will be the position of image? You see these two rays, they are not coming close neither going away, so they will move till infinity, and we will have to assume that they will meet at some point in infinity and a real and inverted and magnified image will be formed. Moving on to the next part, that is if we keep the position of object between f1 and o, the position of image will be on the same side of the object, it will be virtual and erect, and the red line and black line you compare, so the image will be magnified as compared to the object, so it will be having a larger size. Moving on to the next one, now we have concave lens. In concave lens we will see two different cases. If the object is at infinity, the light rays are coming and diverging, so if we bring them back they will combine at f1 on the same side. So if we are elongating the light rays backside, so that is why nature is virtual and erect, and size, as you can see, we cannot see the image properly, so it is highly diminished. Moving on to the last one, and that is if we keep the object between infinity and optical center of the lens, what will happen? Image will be formed again on the same side, it will be formed between f1 and o, and if we see the image, very small tiny image you can see, Again, it is virtual and erect, and it is diminished. That means smaller than the object. So here we complete the ray diagrams. Moving on to the next topic, that is uses of lenses. We'll see uses of both the kind of lenses. Convex lens is used in magnifying glass and microscope. Concave lens, on the other hand, it is used in flashlight and spy hole indoors. You cannot see this commonly in India, but in foreign countries they are keeping spy holes indoors for their security. Moving on to the next point, that is sign convention for lens. You can see this pattern is repeated. We are following the same set of rules that we have followed for mirror. Here optical center is considered as the origin, and if you move towards left side, the distance measured will be negative. If you move towards right side, distance measured will be positive. Perpendicularly above is positive and perpendicularly downside it is taken negative. Friends, especially we have to take care of these sign convention when you are solving numericals. Moving on to the next topic, that is lens formula. Again, we are seeing similar concept as that we have seen in mirror. What is lens formula? It is the equation which gives relation between object distance u, image distance v, and focal length f of a lens. So this formula, this equation is called lens formula. Moving on to magnification. Again, magnification is the ratio of image height to object height. So it is expressed as h dash upon h. Also, it can be expressed as image ratio of image distance to object distance. So magnification is denoted by small m. So we can write small m equals to h dash upon h, and small m is also equals to v upon u. Note that again we have to follow Cartesian sign convention if we are finding magnification. Moving on to the last topic, that is power of lens. What is power of lens? It is the ability of a lens to converge or diverge light rays. So everything depends on focal length. If the focal length is changed, the ability of lens to converge or diverge the light rays will also change. Technically, if we define power of lens, it is the reciprocal of the focal length of the lens. Power of lens is denoted by P. So we can write P equals to 1 upon F. We have to take care of some points, that is power of lens is measured by a special unit, that is diopter, and for finding power in diopter we have to take care that focal length must be in meters. So standard unit for power of lens is diopter. Instrument used to measure the power of any lens is dioptometer. So unit and the instrument both are starting with the same names, so that is why it is easy to remember. One thing we have to keep in mind, that power of convex lens is positive and power of concave lens is negative. This will help when you will solve numerical related to power, right? So that is all about refraction. We have completed reflection in the previous video. In this video we have completed refraction as well. So thank you students, and stay updated for the next set of videos in which we will study another topics of